At this point, we're ready to go. So first of all, we're going to be talking about shifting left and what shifting left actually means when we talk about DevSecOps and development security. So let's have a look at how GitLab actually enables us to shift left and catch our security mistakes at the merge request instead of months later when it's spotted by a random security scan. You might have heard the term shift left before. If you haven't, what it actually means is typically in older security processes, what we see is that security reviews for any new code is done quite late in the process, or there might be no security review. So the way that a vulnerability is found inside that development security process is either by someone exploiting it in production, which is the worst case, or maybe by a security team who gets involved quite late in the development process. And over the last few years, with the growth of DevSecOps, we've seen this idea of shifting security left. And what we mean by that is taking that vulnerability identification process and moving it as close to the development process as we can. And what that means is that developers get feedback about any security vulnerabilities as fast as possible in the process. And then they can fix that and react to it while they're in context, while they're writing the code, rather than getting called at 3 a.m. when it's found by a security scan or maybe by an operations team who've identified a data breach. And then you have to think about what you did months ago. How did you write this code? What other things do you need to account for? And it becomes really costly and really painful to fix these security mistakes. So we want to give you the ability to identify these things fast and fix them fast. So a little analogy for why you might want to shift left. Let's imagine that we're out in the woods and we're building a shelter because we know there's a storm coming. On the left-hand side, we've got our shelter that we've built without shifting left. And what this means is, we've gathered some sticks, we've gathered some logs, we've built this shelter, and we're hoping that when the storm comes, it's going to hold up. And sure enough, when we're sitting there underneath our bad shelter, the storm starts to rain down, the wind starts to blow, and the shelter collapses in on us. And in the middle of this storm, we've realized that we didn't build a resilient enough shelter to withstand the power of the storm. And now we're left wet and cold and hungry, and we need to try and rebuild our shelter in the middle of the storm. So this is obviously not a great situation. Wouldn't it be a lot better if while we were building the shelter, we could test out whether it was going to be resilient enough against the storm? Maybe we could, push on some of the logs or have someone throw stuff at it, tip some water on it to make sure that no water gets into the shelter. And then, even if the shelter breaks while we're doing this, at least we know that it's not going to work before the storm hits us, and we can react to that and make sure that by the time the storm does hit, we have a shelter that's going to keep us safe and warm. And this is really what shifting left is all about. We want you to discover holes in your development process and your security process before the storm comes and a data breach happens or you get exploited or something like that. So really, it's about continually testing and getting feedback fast in that process while you're developing and while you're building. We at GitLab run a DevSecOps survey every year, and there's been a bit of a movement for shifting left, which we've observed. So I've got some snippets of our DevSecOps report, our State of DevSecOps report. As you can see, security scanning has actually increased a lot over the last few years. So across the board, developers are reporting greater use of static analysis, dynamic application security testing, scanning their containers that they're building. The industry is kind of moving towards this idea of automating security scanning and shifting it left earlier in that development process. We've noticed that 57% of security team members have said their organizations have either shifted left or are planning to this year. And 43% of security professionals feel somewhat or very unprepared for the future. And that's really what shifting left is trying to solve, giving you confidence that you're doing everything you can right now to prepare for threats in the future. Now, I've got a QR code on the bottom left here and also a link to our GitLab DevSecOps developer survey from last year. So we have a few breaks in today's session. Feel free to scan that QR code or open up that link. It's worth a read in some of the breaks today if you want something to look at. When it comes to shifting left, we believe that GitLab is uniquely positioned to help achieve that. So we like to imagine this kind of clock where security becomes this iterative, continuous process. So GitLab supports you in developing new features and committing new code. It also supports you by analyzing your code for security vulnerabilities. So we're going to explore today some of the analysis tools that GitLab provides for analyzing commits for security vulnerabilities. GitLab also helps you mitigate any findings that you have in that security pipeline. So we'll use things like our explain a vulnerability feature, which uses AI to actually help you identify and mitigate any security vulnerabilities that are found in your development process. And we also have other things like suggesting versions that you should update to protect software dependencies from vulnerabilities and things like that. We also have features to help you detect security attacks within cloud-native environments. So things like scanning containers inside Kubernetes clusters and feeding that all back into your GitLab development process as well. And with any security findings inside GitLab, they easily tie back into the development process. So you can do things like folding security findings back into your agile planning strategies so that you know that any security findings are being treated as part of the development lifecycle, and you get this kind of continuous feedback loop. So what does security testing and shifting left actually look like inside GitLab? Now, we're going to see real examples of this today, but the way it works inside GitLab is you'll notice this workflow sort of moves from left to right here. So we have our main branch or our master branch. Typically inside GitLab, a developer will create a merge request and start working on a feature branch. As they add code to that feature branch, in the background, there's going to be CI pipelines and security scans that kick off and run against that the code in that feature branch. So as a developer, every time you push a new commit, you're going to get feedback from GitLab on that feature branch and inside that merge request that's going to tell you any security vulnerabilities that you might have accidentally introduced. So while you're writing the code, you're getting fast feedback. You can see any vulnerabilities that you may have introduced and remediate them while you're in that development process and in that right mindset. From then, you can kick off discussion, code security, code reviews and security reviews. And you can also build out approval workflows to make sure that any code that you're adding has the right people sign off on it. So then by the time that your code hits the main branch, you have a really high level of confidence that it's gone through this rigorous security scanning process and the right approvals so that the code that lands in your main branch, you can feel confident about. In this case, the code that hits your main branch, we've already tested it against the storm. It's not going to be a shelter that collapses in on you, when you push it into production and the storm starts. So hopefully by now you understand what shift left is. Let's get our hands dirty with some real workshop material. So the first thing we're going to be doing is working through the issue number 1 in our workshop repo, where we're going to explore how we actually shift left with GitLab. So I'm going to jump across and do that now. Feel free to follow along with me. Also, you should have your own copy of the repo and the workshop issues by this point. So if you want to work ahead or work at your own pace, please go ahead. Otherwise, you can follow along with me. Okay, so I'm just going to set up my split screen setup that I mentioned before. Okay, so I've got my copy on the left-hand side and we've got our issues on the right-hand side. And we're going to be working through number 1, shifting left. So let's open up this issue. So the first thing we're going to do is we're going to add some security scans to this repo. So as I mentioned before, this repo here is a Python project that we've put together for you with some real code that we're going to use in our security scanning workshop today. So what we're going to do is we're going to take some security scanning templates for GitLab CI, and we're going to add this to our project. So first of all, let's have a look at our security pipelines, or at least our pipelines that we've already got. So I'm going to go to the pipeline editor to view that. If I go down to build pipeline editor, we can have a look at the CI pipelines that our project is using at the moment. Now, this is our GitLab CI template for our workshop project. And if we have a look at it, you can see we only have one stage called build. And all we're really doing here is building a Docker container. If you look closely at this, there's really nothing in the way of security. We're not doing any security scanning. We're not doing any automated testing. We're just building a Docker container and we're pushing it to our GitLab container registry. So we're going to fix that. We're going to add some security scans and start this kind of shift left movement inside our organization. So what I'm going to do is I'm going to take the content from the issue over here and copy and paste it. And I'm just going to replace it with the CI pipeline from the issue. Now, as you can see, a bunch of templates appeared up here. So what we've actually done here, the main security scanners have been included using this include statement. You can see here we have include template jobs/SAST, jobs/secret detection. So in GitLab, all of the security scanning features are just templates that you can include, and they do all of the heavy lifting for you, doing things like identifying what language you're using, identifying what build tools you might be using. So when you include these templates, you're ready to go. We've done shift left just like that. Now, if you wanted some more details about what these templates are actually doing, you can click full configuration over on the pipeline editor. As you can see, it's quite a large file when all the templates are expanded out. And the reason why is all of the logic to detect the tools that you're using and run the correct analyzers are all in here. But if you want to see what's going on under the hood, you can always do that. If you're having any issues getting access to the pipeline editor or copying the CI/CD file from the issue into your pipeline editor, please let us know. Now, what I'm going to do here is I'm going to change my commit message. We're going to get ready to actually commit this. And I'm going to make my commit message something useful. So I'm going to say, add security scans to enable shift left security for Tanuki Racing. Now, we don't want to commit straight to the main branch because we're good developers. So I'm going to call this branch feature add security scans. And we're going to click start a new merge request with these changes. This is going to bring me to the new merge request screen. I'm going to add a quick description. This MR adds security scanning to our project for shift left security. I'm going to assign myself. I'm going to untick delete source branch when the merge request is accepted, just so we always have that merge request there. And I'm going to create the merge request. Okay, now we have a new merge request, and you'll notice that we've got some pipelines kicking off. Now, these pipelines will eventually have all of our security features and our security scan results, but they take a little bit of time to run. So we're going to let these kick off, and we're going to keep working through the workshop, and then we'll come back and have a look at the results in a minute. So I'll just make sure these pipelines are looking good. Okay, just waiting for that job to be picked up. Let's come back to that in a minute. Okay, now I'm going to continue along. So we have added the security scans as step 1 for our issue. Now let's have a look at GitLab Duo. So if you're new to GitLab and you're new to GitLab pipelines, you might be wondering, how do we actually view the pipelines, view the results, things like that. So if you are a bit lost at any time during this workshop, what you can do is use GitLab Duo to actually ask questions. And this is one of our AI assisted tools that is specifically trained to answer GitLab questions. So I can show you how to do that. If you go down to the help section at the bottom of the sidebar and click on GitLab Duo chat, this is going to pop up a chat, and you can ask anything you want about GitLab in here. So I could say, for example, what security features does GitLab have? And in a few minutes, GitLab Duo has started responding to me and is giving me a comprehensive overview of the security features inside GitLab. So if you have any questions today, obviously you can use the Q&A. We have GitLab folks watching that at the moment to help you, but also give GitLab Duo a try. You might get a faster answer and a more detailed answer. So again, just jump down to that help button at the bottom of the sidebar and click GitLab Duo chat. Okay, cool. My pipelines are running now. That's looking good. All right, so we've got our merge request created. We've got our security pipelines executing. Let's leave that for a moment and we'll come back. So we've configured or completed all 3 steps of our first issue. We're ready to move on to issue number 2. Now we're going to be having a look at compliance frameworks inside GitLab. Okay, so what we showed just before is that we can set up a new pipeline for security tests, but now that we're in charge of security for Tanuki Racing, we don't really want to go around and configure security pipelines for every project that our developers set up. Even more so, we might not even have visibility of some of those projects because we want developers to be able to move fast and create their own projects and get out of their way. But we want to make sure that we are applying security consistently across our organization and across all of our different projects. So in GitLab, the way that we do that is through security policies and compliance frameworks. So we're going to show you today how you can actually set up a pipeline that has to run to make sure that any security requirement or compliance requirement that you might have, you can enforce using GitLab compliance pipelines. Now, the way that we do this inside GitLab is what we call compliant workflow automation. So really what this means is coming up with rules and policies that enforce how our compliance workflows are going to be executed inside GitLab and making sure that we have separation of duties. So for example, someone who is responsible for security can set up these compliance pipelines, and then developers have to abide by those compliance pipelines. They can't override them or circumvent them in any way. So inside GitLab, we have a few ways to do that. We have compliance framework project templates. This allows you to create your own compliance projects and compliance pipelines that map to any specific audit protocols such as HIPAA or NIST or SOC 2 that you might require inside your organization to make sure that the requirements of SOC 2, for example, are being met consistently across all the projects inside your GitLab repository. We have compliance framework project labels. So this allows you to apply different compliance frameworks to different projects. So for example, you might have some projects that have higher compliance requirements than others, or maybe some area of the business that requires certain levels of compliance. Compliance labels make it really easy to identify and apply compliance frameworks to different projects. And then we have compliance framework pipelines. So compliance pipelines inside GitLab actually allow you to build out any kind of workflow that you want that as a part of that compliance requirement. So you might want something like making sure that security scans are being run consistently across every pipeline, or maybe that artifacts are being created and stored in a consistent way. You can do that, or any other really organizational requirement that you have, you can build out with a compliance pipeline. So what's the benefit of GitLab compliance pipelines? Well, first of all, you make sure that developers are following best security practices consistently. No one can circumvent it. There's no one kind of going off doing their own thing and not following security practices, which is especially important if you are trying to meet a compliance requirement, which requires consistency across all the different development activities that might be happening. You can easily maintain different kind of compliance frameworks and labels. So as I mentioned, some projects might require high levels of compliance than others. GitLab makes it easy to manage that at scale. You can prevent developers from skipping necessary scans when they're trying to push out code at the last minute. So maybe if you have, some kind of heroes that are going off and pushing code out and not worrying about some security quality practices that you might be trying to apply, this prevents that from happening. And you can also integrate with any external tools. So if GitLab Ultimate doesn't have any scanners that you might require for a compliance workflow, or you need to run an external tool as a part of that, you can use compliance frameworks and compliance pipelines to call out and integrate with any third-party security tooling that you need. Okay, so let's get started with issue number 2, compliance framework. So again, feel free to follow along with me or work ahead at your own pace. We're going to jump into issue number 2 now. I'm going to jump back into my project. And I'm going to jump back out to issue number 2 inside the workshop project. Perfect. Okay, here we go. So let's create a compliance framework that will be enforced when we merge our code into main. So as I mentioned, compliance frameworks allow us to define some kind of workflow that needs to be run across our projects or across our organizations. So first of all, we're going to be defining our compliance framework. Now, we've done this for you just to make it a little bit easier, but you'll see there's a link in the issue that can take you to the pipeline to have a look at what it's actually going to be doing. So here we have our compliance GitLab YAML file. We can open that up. So first, let's take a look at the stages section, where each stage defined must be run in order for the pipeline, in order for each pipeline the framework is applied to. Notice the pre-stage starts with a dot, so it doesn't have to be defined to be run. So you'll see here we have a compliance job in stage .pre. This means that this job here, compliance job, will always run. Now, we also have an include statement here. What this does is make sure that any compliance, any user provided pipeline, so if a developer creates their own pipeline and then we apply this compliance framework over the top, we make sure that we also include the CI file of the project too. So this kind of makes sure that we merge any developer defined pipelines alongside our compliance workflow. We've defined a compliance job that will run during the pre-stage and just prints out a message to let the user know the framework has been applied. So that's this job here. So in our compliance workflow today, all we're doing is printing out a message just to keep things simple for the workshop. But you can imagine that in this compliance job, you could define any script that you wanted. So whether that's running some tool or interacting with an API or building out some artifacts that you're going to upload somewhere or share, you can do that in here. There's also a link to the documentation for compliance pipelines, so feel free to open that up and have a look. Follow along with how to actually add this to the project. So now we're going to be applying the framework to our project. So I'm going to jump back over to my copy, and we're going to go to Settings and General. I'm going to scroll down to Compliance Framework and expand. Now we can choose a framework to use from our group. And notice we have the security and compliance workshop framework ready to apply. So I'm going to add that, and I'm going to save changes. If we jump back to my project now, you'll see we actually have this label up the top here that says security and compliance workshop. So now we know that this workshop project has this compliance label attached to it. So this could be anything that you would like. If you, for example, wanted to build out a compliance framework for SOC 2 or ISO 27K or NIST or something like that, you could similarly apply that as a label and then have the pipeline defined for any controls that you might need as part of that. Okay. So that's step 1 and step 2 completed. We have applied our compliance framework to our project, and we are done with issue number 2. All right. Get ready for lap number 3, parsing the results. So here's where we are in the workshop. So we've talked a little bit about what shifting left is and how we might enable a shift left philosophy inside GitLab by enabling some security scanners in our pipeline. We've also looked at compliance frameworks. We've set up our own compliance framework inside our project that we created. And now we're getting ready to parse the results of our security scanning that we set up in the shift left section. You should see a poll popping up now. We just want to check in with you guys and see how you're feeling about the pace. Let us know if we're going too fast, if we're going too slow, or if it's just right. I do get a lot of feedback that I speak really fast, so don't feel bad about saying that. I know I'll try and slow down. Okay, cool. Looks like a few of you are saying we're moving a little bit too fast. I totally understand. This is a pretty complicated workshop and there's a lot of content, so please bear with us. I will slow down a little bit. Now, let us know where you're up to. For those of you who have said that we're moving a bit fast, please feel free to jump into the Q&A. Let us know where you're up to. Let us know where you're stuck, and we'll help you out to get you back up to where we are at. Also, if you are a little bit behind, feel free to just continue working through issue number 1 and issue number 2 in that workshop. So if I jump back to the content, just to let you know where we're up to, we've worked through shifting left as issue number 1, and we've worked through compliance framework as issue number 2. So just continue plugging away at those. Don't worry if you're a little bit behind me. We do have some breaks, so there'll be plenty of time to catch up during the breaks as well. But I'll give everyone just a few seconds to respond. I'll check the Q&A here. How are we doing? Oh, that's okay. So if you are seeing that the merge request, the pipelines are pending, that's all right. Give it a few minutes. We're just waiting for the GitLab runners to pick up the jobs. So again, if you are feeling like we're moving too fast, guys, please let us know where you're up to in the Q&A. Happy to help you out. Awesome. Looks like about half-half. So it's good to see. A lot of us are keeping up. Again, don't feel too bad if you're a little bit behind. I know I move really fast. I get excited. I can't help it. Just continue working through those issues. And yeah, I'll slow down a little bit now just to see if we can catch up. Is it correct to assume that the compliance GitLab CI.yaml is what's been applied? Yeah, that's right. So this question here from Keng, that is exactly correct. So if you look in the issue, in issue number 2, you'll see a link to the GitLab YAML file that is being applied using that framework. If your question is, how would you find that when you're kind of managing this on your own? If you have the ability to edit the compliance framework, which sometimes you can't, depending on what permission you might have, you can actually see which YAML file is assigned to which compliance framework label. Just a quick reminder too, that the demo environment will be available to you for 48 hours after this workshop. So again, if you are falling a little bit behind, you will have access for a couple of days if you wanted to play around or try and catch up and work through in your own time. And towards the end of the workshop, we'll also clone the project into your own environment. So you will always have a copy of it if you would like. Thanks, Ken. Yeah, that's right. So typically, the reason why you can't see the YAML file in the forked repo, comes back to that separation of duties type idea. So we want the compliance framework pipeline to be defined and managed separately from the projects that it's actually managing, if that makes sense. And the reason for that is you might have some compliance framework or some compliance workflows that you want to apply to the projects. And developers should be able to edit all the files inside a project, for example, without being able to edit or circumvent that compliance workflow. So that's why they're in separate repos. But it's a great question. Okay, cool. Thanks so much for responding to the poll, everyone. I appreciate the feedback on the pace of the workshop. I'll try and slow down a little bit as well. But again, just a reminder, just keep working through those issues and let us know in the Q&A if you get stuck. No issues if you're a little bit behind. And thanks for all the great questions so far. These are fantastic. Okay, cool. I'll jump back in. So now we're up to parsing the results. So we're going to have a look at some of the security scanning feedback that we configured in the first issue. So if you remember, we created a merge request with some security scanning additions in our first hands-on exercise in today's workshop. We've given it some time to execute. So now we're going to have a look at some of the security scan results. We're also going to create some policies that we might need to prevent any security breaches in the future based on some findings inside our scan results. So firstly, I want to run through some of the scanners that we have actually utilized in today's workshop. First of all, we're using static application security testing or SAS testing. So these are terms that you might be familiar with. Basically, a SAS scanner actually analyzes the source code for known vulnerabilities as part of development. So what this does is it looks at the actual code itself. For example, you might have a command execution inside your Python or something like that. The SAS analyzer will inspect the code. It sees that you're executing a command, and it might see that you're executing a command with user input, and then it will notify you that that's a potential vulnerability. So SAS testing actually looks at the code itself. DAS testing, dynamic application security testing. Now, this analyzes a running application for vulnerabilities by seeking to hack into your application. So inside GitLab, what this means is that we take a running version of your application that might be inside a Docker container. We run that inside the CI pipeline, and we try and actively exploit that application to find vulnerabilities. There's a few other ways you can configure it. In our workshop today, we are running our Python app as a container and trying to execute exploits against it. So you can kind of think of a DAST scan as like a miniature pen test inside your CI pipeline. Container scanning. Inside today's workshop, we're building a Docker image as part of our workshop project. We also will scan the Docker image itself for known vulnerabilities in the application container, plus any of the base images that we might be building on top of inside our Docker file. We're also using dependency scanning. So we're using Python. We've installed packages from PyPy using the pip package manager. We want to make sure that we're not only scanning our own code, but we're also scanning any third-party dependencies you might be using from the internet. Typically when we talk to development teams, sometimes a huge majority of the code that they're using inside their project comes from third-party dependencies. So you don't want that to just be this kind of black box. You want to make sure that you're also scanning those dependencies for vulnerabilities as well. License scanning. So when we're using open source libraries and dependencies, sometimes they can have licenses that might impose conditions on us that we may not necessarily want to accept. So things like making sure that we open source our own code or something like that, we may not want to do that. So inside GitLab, we can also configure license scanners to make sure that we're only using licenses that are compatible with our own license as a development house. We want to make sure that we don't open ourselves up to any legal risk as we develop. And secret detection, another really important one. So it's pretty common to accidentally check in a secret into source code management. So GitLab secret detection will check all your commits. We also have automatic revocation. So if we do detect that, for example, you've accidentally committed a AWS token into your source code repository, we'll not only tell you about that, but we'll also assist you with revoking and rotating that secret too, to make sure that now that it's been exposed, it can't be used against you. Now, what we're going to do in today's workshop is also explore scan result policies. So when we go through the hands-on exercise, we'll show you some security vulnerabilities that you might find as part of your development process and how you can respond to those findings with security policies. In GitLab, security policies are broken down into two categories. We have scan result policies. These basically are what should happen when we do find a vulnerability inside a pipeline. So if we find a critical vulnerability, do we want to require approvals from the security team? Do we want to require approvals from a senior developer or something like that? Scan execution policies define what scans should be run throughout the organization. So we can do things like making sure we use, on the right-hand side, you can see an example of this. We want to make sure that, for example, we run security scanning, let's say secret detection, on every pipeline that targets a main branch. Or we might say we want to make sure that we do SAS testing across every branch, for example. So GitLab allows you to easily configure these policies and apply them consistently, so you know that some level of security is being applied across all your projects in GitLab. So let's have a look at how we actually set this up with our hands-on exercise number 3. So after this exercise, we're going to have a little break as well. So if your brain is exploding at the moment, we're nearly there. Stay with us. Okay, so let's jump into issue number 3, parsing the results. So we're going to have a look at the results of our pipeline for the merge request, and we're going to merge the code to generate some security reports. So following our shift left trend, we will see how security results are included in each step of the deployment lifecycle. Step 1, merge request security results. So I'm going to jump back across to my project. Now, if you are at the root of your project, what you want to do from this point is on the sidebar, you want to go into code and then merge requests, and you'll see the merge request that we created in our first hands-on exercise. So let's open that up. And now you can see our pipelines have actually completed, and you'll notice that we have some security scanning results down here as well. So below the approval section, we can see code quality, license compliance, and security scanning. Now, what's nice about this is we've made some changes, and before they've even gone into the branch, we've got a bunch of useful information. So obviously at this point as a developer, I've got this feedback in real time. I can very easily jump back into my merge request, jump back into my code. For example, I could just open this back up in the web IDE and start to work on some additional commits to start remediating some of these vulnerabilities that I might have accidentally introduced. So let's have a look at some of our results. Now, when I open up the license compliance scanner, we can see I don't have any license policies, but GitLab has helpfully identified a bunch of licenses being used by my packages. So if there's anything in here that would be potentially legally scary for my organization, I can easily identify that, and I can use the policies to make sure that these don't get merged. I can also open my security scanning results. And we can see here, we have a bunch of vulnerabilities. So we've got some problems with S3 buckets that have been exposed to the public. We've got lack of encryption, and these are some of our infrastructure as code scanners. We also have some encryption issues. We have some container scanning results. So coming from using old container images or base images that have vulnerabilities in them. So you can see how helpful it is to have all of this vulnerability information in this merge request view. So now that we've looked through the results, we can read up on why a particular vulnerability is a problem. So let's say that we see one of these things and we don't really know what it is. In this case, S3 buckets should not be readable to all users. I can click on this. I can click on the identifier, and it's going to take me straight to the AWS documentation to give me some more information about why this would be a problem. I can also click on the file and jump straight into where this has been detected. As you can see, what's happening here is this is a CloudFormation template where I have public read access on my S3 bucket. So this is the problem. I need to change this to something that's private so that I don't expose my S3 bucket to the internet by accident. Now I'm going to scroll down and we're going to merge this. So we have a bunch of security vulnerabilities, but we're going to merge that anyway just to see the other views that GitLab provides us. Okay. Now we've kicked off the pipelines on the main branch. If I jump back to my project, you can see we've got pipelines running. So we're going to go into a little bit of a break while we wait for these pipelines to run. All right, so let's have a little 10-minute break while we wait for our pipelines to execute. If you're a little bit behind, we'll all still be here. So if you have any questions, feel free to ask throughout the break. Otherwise, we're going to give a little bit of time for those pipelines to finish running and for people to finish catching up, and then we'll jump back in. So please go grab a coffee, have a bathroom break, or continue working away, and we'll be here to answer any questions. Welcome back, everybody. Hopefully you had a good break and managed to get some coffee or tea or write some more incredible pipelines. Let's take a look at our pipeline that we kicked off before the break. Okay, we're all done. Okay, so hopefully all of you have managed to get to this point. You should see a bunch of completed CI/CD jobs. And we're going to continue onto step 2, parsing the results. So our pipeline is finished on our main branch. And now we're going to see some reports that have been generated under our security and compliance tab. So these will only be generated when security scans run on the main branch. So if we jump back to our workshop project, to the main screen, and we go down to secure and security dashboard. This is our security dashboard screen. It looks like it hasn't updated yet. Sometimes this takes a long time to collect data. So if it hasn't got any results yet, you can open up our security dashboard on gitlab.com in the link in the issue. So on the right-hand side, you can see the example of our security dashboard. Sometimes this can take up to 24 hours to update once you have new scan results inside your main pipeline. It might be a little bit quicker. It just depends on the pipeline. Okay. So next, let's have a look at our vulnerability report to view our full security vulnerability report. Go down to secure, vulnerability report. So this is our project level vulnerability report. When we looked at the scan results before, we were looking at our merge request vulnerabilities, which only contain security vulnerabilities that pertain to the merge request that we opened. This report here is a holistic view of all the vulnerabilities inside our project. We can see when they were last updated, in this case, 14 minutes ago from our pipeline that we ran. We can see when our software bill of materials was last updated. We can see a breakdown of all the vulnerabilities across the project by severity. Now we can also change and filter here. So if we want to see different statuses of vulnerabilities, different severities, and we can also view and filter different tools that detected those vulnerabilities. So in this case, we want to change all tools to filter on SAST. We can see a bunch of the S3 bucket vulnerabilities that we saw before in our merge request view. Another really cool thing you can do here is if you jump into the vulnerability and get more details. So this is the vulnerability screen, which will give you more details about what the vulnerability is, where it was detected. We also have this really handy feature inside GitLab for explaining vulnerabilities and how to mitigate them using AI. So if I click this explain vulnerability button, in a few seconds, I'm going to get a response here from a AI. So you can see here, this is an explanation of, in this case, we have a badly set encryption parameter inside one of our Python function calls. So it explains what this vulnerability actually is. It explains how you might actually take advantage of this to decrypt data inside an S3 bucket. So why this is actually a problem and how it could be attacked, and also how to fix this. So basically, inside our S3 bucket configuration, we need to set a reference to a KMS key to make sure that everything inside our S3 bucket is encrypted. So very handy, and also takes into account the surrounding code. So you get explanations about vulnerabilities and how to fix them from exactly your context. All right, cool. So we've had a look at some of the vulnerability reports and screens that GitLab provides for us. Let's jump into step 3, preventative security policies. So I'm going to jump back to the vulnerability report. And if we go to severity and then critical, and we change our tool to secret detection. Oops, there we go. You'll see we actually have 2 critical secret detection vulnerabilities here for leaked AWS access tokens. So we want to prevent this from happening in the future. We've found that someone has accidentally committed access tokens into the repository, and we've only found them after we've added these scans. So how do we prevent this going forwards? Well, what we can actually do here, in this case, leaked tokens are easy mistakes that can lead to massive problems. So we're going to create a quick policy to stop that from happening. On the left-hand side, we're going to go back to our secure tab, down to policies. And we're going to create a policy here. New policy. I'm going to create a scan result policy. So as you can see, this creates rules that check for vulnerabilities and license compliance before merging a merge request. Now, I'm going to call this secret, call this default secret detection. I'm going to say when, in this case, okay. Under the rules section, we want to change all scanners to be secret detection and all protected branches to the default branch. So we'll change this to default branch, and we'll make this into a secret detection only. And we want to say if we find any vulnerabilities based on our secret detection scan, we want to require an approval. In this case, I'm going to make this my colleague Logan. As you can see, GitLab policies are managed with a YAML file similar to our CI file. We have this helpful graphical editor, but under the hood, it just generates the YAML. So you can manage and configure these policies using version control and all the benefits you get from using Git. Let's configure this with a merge request. So what this actually does under the hood is it creates a policy project. Again, this comes back to the idea that we were talking about before in the Q&A, where we've separated the idea of managing the security policies from the repo itself, so that we can have separate permissions and things like that. It keeps that separation of duties, which is so important for compliance, gives us the ability to do that separation of duties. Now let's merge that code into our security policy project. And let's go back to our group and back into our workshop project. As you can see, we now have the security policy project separate. All right. For step 4 on our hands-on issue number 3, we're going to be taking action on our vulnerabilities. So we've got that protective policy in place. Let's go ahead and make sure it works by removing the secrets in the code base. So let's go ahead and open up our web IDE. I'm going to go into the run.py file. And we're going to add a fake AWS token to see if our code works. So we've added a fake token in here that we're going to use to check our scanning policy. I'm going to create a new branch here. and create a merge request. As you can see, the merge request is now blocked. So we didn't have this before. And you can see here, it requires one approval from default secret detection, which is the name of the security policy rule that we just configured. If we look in our pipelines as well, you'll see we have secret detection that runs. And my colleague Logan, who we assigned as the approver for our policy, is now a required approver. Now, the reason why this is blocked at the moment is because the scan hasn't run, so we don't know if there's any security violations here and any leaked tokens. If there isn't, then that's great. It means that Logan doesn't have to get involved as an approver. But if GitLab does find leaked tokens, then it means that Logan has to approve that. Obviously, in your case, it could be yourself if you're someone responsible for security inside the organization, or it could be the security team or whoever you would want to be an approver for signing off on something like a leaked token. All right, we've got our new merge request. I'm going to scroll to the bottom, uncheck delete source branch. Oh yeah, we've got a new merge request. And as we can see, we have the required approval. Now, you might want to know what to do when a secret does get detected. GitLab will help you with that. So there's a link at the bottom of that issue for documentation on automatically revoking secrets. We will help you revoke secrets when they're detected if we can. So we have automatic revocation for certain types of secrets, which really helps with making sure that if something does get exposed, it can't be exploited against you if it does get leaked somehow. Okay, and that brings us to the end of issue number 3. We've now completed 3 hands-on sections. So great work if you're up to there. If not, let us know where you're stuck. Now I'm going to jump over to section number 4, SBOM and license compliance. Now, I'm going to hand over to my very talented colleague, Pedrick. And don't worry, we've saved the best till last. So Pedrick will take it from here. So I'm going to stop sharing my screen and give access to Pedrick. Give me 1 second,
Yep.
Pedrick. I'll just give you access to the repository so that you can continue the work.
Sure.
Okay.
So while you're doing that, maybe I can just somehow recap in terms of what we have done this morning.
All right. I just invited you, Pedrick, so hopefully you'll have access to my project to continue on. And for all of our attendees, thank you so much for sticking with me through that. I know it was a lot to cover. I will now leave you in the hands of the very talented Pedrick.
Thank you. Let me just put it up. Yep. Okay, I hope everybody can see my screen. So just to kind of basically just recap a bit, right? So I think what we have done this morning with the fantastic job of Ben, right, to actually showcase kind of basically how in GitLab itself, you can very easily integrate in terms of the different scanners and basically tightly shift left, approaching basically the APAC best practices as part of your delivery cycle, right? And then as part of governance and controls itself, where you can actually use compliance frameworks to enforce certain example scans, or it could be used for other purpose, right? And including basically policies and basically walking through in terms of the different results, right? So in this section, what I'm going to talk about is talking about SBOM and license compliance, right? So what is SBOM itself? So SBOM, in short, in long term, its actual term is called software bill of materials, right? So basically it is basically a composition or basically a breakdown of in terms of the dependencies, that you kind of have, and why do we actually need a software bill of materials, right? It's because of the upcoming, many high-level hacks that happens on the headlines, right? So just to kind of basically make it a bit more interactive, I want to run a poll in terms of some of the supply chain attacks, just to understand, and somebody help me switch in with the polls. Yep. So I just launched a poll that has basically, a number of different types of, possible supply chain attacks. So I just, want to understand, whether you guys are aware of those. So forgive my voice. I know it's very sexy because I'm having a bad sore throat. Right. So I'll probably end the poll right here. Right, and just share the results. Right. So the correct answer for this particular, poll itself is all the above, right? So in case that you might not be aware, so just to highly explain in terms of some of the different types of attacks. So typo squatting is kind of basically trying to basically hijack, leverage on, typos that's coming from, developers who is keying in basically URLs of the dependencies and key it wrongly. So maybe you're trying to get something like Next.js and then you miss out T. So you end up hooking up and then downloading basically wrong dependencies, right? Protestware is very, very interesting kind of basically new supply chain attacks that it's like, it's not coming from the what you call it, the black hats, but it's coming from the white hats, and more specific, is actually coming from your contributors, the open source codes contributors, whereby they kind of basically have an agenda, right? So just like the Ukraine Russia war that happened, so a number of basically attacks came out whereby the contributor was actually putting kind of basically malware within the protestware itself, and then in some cases it's got really serious, whereby if it sends that you're from Russia, it kind of basically deletes away everything that is on your laptop. All right. So coming to repo jacking. So repo jacking is sort of basically similar, whereby you're doing some form of URL confusion, right? Leveraging on like typos or basically a DNS rerouting that comes with it, right? Then dependency confusion. So this is a very interesting one, whereby basically you kind of basically have your private dependencies that you are building it on your own, and basically your public dependencies. But when you actually what happens is that as configured as part of your package managers, you might become directly just in order itself, whereby you'll be hooking up to the public repositories. And what happens is that if kind of basically a hacker actually gets to know that basically you are using certain form, or you have certain form of private libraries with certain meme formats. So they actually place kind of basically a malware dependencies that is using the same format, the same naming convention as you are, right? And put it on the public repositories like npm repositories. And what happens when you actually do kind of basically a npm install or npm update, right? You actually end up grabbing the private libraries, not from your own private repositories, but actually ending up pulling something out from public, and that could contain certain malware, right? So these are all the different types of forms of supply chain attacks that pops up, right? And if I just go through certain slides, right? So I'm not so sure whether you guys actually still recall, like in the end of 2020, near Christmas time, right? Basically, we had basically an outage, or basically a very big attack that was or vulnerability that was discovered on the popular open source Java logging library, Log4j, right? And the first thing that really kind of basically hit was, when I hear from customers was not like, oh, how do I fix this? The first thing that came out from a lot of customers was that where am I using Log4j? So detection was the first thing that pops up, or basically identifying where Log4j was actually being used throughout the organizations actually pops up first before, kind of basically figuring out how to fix it. Right. So that is why from the Biden administration itself, right, driven order from them was that actually to require basically software companies to help, to deliver or to maintain a software bill of materials, right? And a software bill of materials basically is a mix of, all the open source libraries or basically, the dependencies, containers, it could even go down to like the different vendors that you are using, different OEMs, third-party software that you're using, right? That is being properly captured, and basically you are doing sort of a continuous monitoring on it to make sure that you're managing all the vulnerability that could possibly pops up from all this as part of your supply chain, right? So what is going to happen is that in our next exercise, we actually explore a GitLab generated SBOM report, right? So the SBOM report basically contains like, dependency name, version, licenses, packages, and etc. Right? And then we'll basically, look into, how you're going to see how each dependencies actually relate to basically a known vulnerability, right? And we're going to download basically the SBOM report. So the SBOM report is basically in the Cyclone DX format. So Cyclone DX is actually an open format for SBOM. Yeah. And it's based on OWASP itself, right? So let me just switch my screen. So let me just put it side by side. So we're going to start with basically Lab 4 exercise, software beyond materials, right? So let's hit in. So this is basically the project that Logan was previously using. Let me just resize the screen a bit, just to make it easy for viewing. All right. So as part of the exercise just now, so Logan had, not Logan, but basically Ben has actually, showed you how you can actually include dependency scanning, right? As part of basically the scans, as part of your pipelines. And along with dependency scanning, that's where basically you can get a breakdown of the dependencies list, or what we call the SBOM. So you can just go on the left panel, and on the left panel itself, that's where basically you can go to dependency list. And on dependency list, that's where basically you can see the different dependencies that are included in your repositories, or basically the applications that you have, right? So you can look over here. So you kind of basically got different components. In this case, this is basically pip. This component was added using the pip packages, and we actually found identifications of basically how we identified this Flask bootstrap was in. So it's actually located in two different locations, right? So basically requirements.txt. So that's basically the package manifest, right? Which actually defines it, right? Additional to that, you can also see basically the licenses that was actually tied to this particular components that comes with it, right? Let me just go into the project view instead of the group view, just not to confuse you guys. Right. So you can see similarly over here. So that's where basically, besides the software bill of materials, so that's like basically your container images that you are bringing in, the base images, what sort of, system libraries that is affiliated with that. So we can give that type of reportings, including basically the different vulnerabilities that is related to that, right? So we can also further go into your dependencies. So just now, that's where basically all the different, dependencies that you have, right, where they are located and what libraries, licenses that they are affiliated with, right? So right on top, so if you want to actually export basically the software bill of materials, so materials, that's where basically you can click the export button, and on the export button, so this Cyclone DX reports is actually reported in JSON format, right? And if you want to know more about basically this particular format, there's a link that is happening inside this lab form that you can actually click to get a more better understanding, right, of that, right? We have also included basically a link, over here that basically allows you to go to one of the blogs that basically showcase how, in GitLab itself, we can actually help you to, during the D-Day attack of basically Log4j, where how through GitLab security features, we can actually detect the Log4j and provide that remediation, quick assessments and basically identifications and, mitigations that comes with it, right? So this is how you will be able to see the software bill of materials, and basically what is happening is that once we have that software bill of materials, we will be able to do continuous monitoring, right? So I think as part of basically 16.4, we have actually enabled new capabilities in terms of continuous monitoring. So that's continuous monitoring. So basically what happens is that we will so once we have basically your dependency list or SBOM itself, that's where basically we'll continuous monitor all these different artifacts, and if it's a new vulnerability pops up, you actually get a notification, right? So heading into step 2 itself, right? So that's where basically, as part of license compliance, right? So there are different types of licenses that, you might be, more aware of, and things are like, Apache license, copyleft license, BSD license, etc. Right? And there are basically some licenses that are very intrusive. Things are like, copyleft license. What it states and then that is that basically if you're kind of basically using me as your dependencies, you also have to open source basically your source codes, right? Your proprietary source codes. So from an enterprise perspective, this is going to be a no-go because of the IP rights that comes with it, all right? So as part of the governance and part of the policies itself, GitLab actually provides that capability. So that allows you to kind of basically filter in terms of, the libraries that is using basically some licenses that is, not allowed by the organizations, and you can actually flag that out, right? So we're just going to follow the step by step, just going to go to security policies. On security policies, what's going to happen is that basically I'm going to click new policies. So once I click new policies, I'm going to select like scans result policies. So if you remember from earlier, you have also basically created scans result policies. But this time around, this is going to be more for the license than basically in the terms of the scanner results. So I'm just going to put in the name, and on the rule side, so I'm going to select license scans, right? And I'm just going to put it kind of basically default, right? And on the status side, I'm just going to select all, right? Just to eliminate, just to highlight in terms of this policy taking effect, right? And basically from the licenses itself, I'm just going to select MIT. Oops, sorry. MIT licenses, and on the approvals ends, that's where basically I'm going to just go one of our colleagues. Yeah, it's called Logan. Right, that's one of the approvals, right? So I'm going to click configure with a merge request. What's going to happen is going to basically, commit basically, sorry, the policy changes, right? Which is policy as code into basically the security policy project, right? So once that's done, what happened is basically I'm just going to merge that. So now I have merged that, and right now if I just go back to my project, and kind of basically hit into the merge request that was previously created. That's where you can see under the approvals itself, that's where basically you can get an additional approval that's required. So over here you can see deny MIT licenses, right? So if you look up basically the full report of the license compliance itself, that's where basically you can see in terms of MIT license that was being found, right? So you can see basically this is how license compliance and policies actually take effect and provides that block merge, right? Approvals process, right? To block basically dependencies that has very intrusive license on you, right? So right now we'll just go back to our slides. Right. So we are now heading into lab 5. So with lab 5 itself, we're going to cover in terms of on-demand scans, audit events, and more. So before we go there, probably what I can do is that we'll open up another poll just to understand in terms of where you guys are headed, right? Just to get a sense of things. Let me just open up the poll. So as we explained earlier in basically in one of our just now in lab 4 itself, right? Kind of basically the importance, the rise of basically threats that's coming into your supply chain, right? And then basically the importance of having a software bill of materials to basically monitor all the dependencies that's coming into your applications, into your repositories.
Hey, Pedrick, you're muted.
Oh, I'm so sorry. Where was I? So basically, just to go through, Lab 5 itself, right? So basically, in terms of the post results, right? So we can see basically this is in line with certain of the surveys that we see that there has been a rise in terms of supply chain attacks that is coming along, and the importance of basically having a software bill of materials, right? To track in terms of basically, the dependencies that you're using and continuous monitoring it, right? So we are headed into Lab 5 itself, right? So on Lab 5 itself, that's where basically we are actually looking to on-demand scans. Sorry, on-demand scans, audit events, and more, right? So in Lab 5, right, so what we have gone through in the earlier is kind of basically securing your applications through the use of basically integrating all the different scanners, enforcing compliance frameworks and policies, and reviewing basically how you can actually review the scans, right? And in certain scenarios, especially in worst case scenario, you might want to have basically, ad hoc scans that is going along. Right, that's where basically you could have basically scheduled scans that is being executed using one of our scanners, right? Things are like dynamic application security testings that comes inside that, right? So we also basically review kind of basically the audit events, as part of your governance process, audit events to update all the events that was taking place, right? So as part of just now the poll that was being run, so you can see over here, I mean, it's been an astonishing, right? 742% average annual increase in software supply chain attacks, right, over the last 3 years, right? And basically 96% of these known vulnerables are actually avoidable, right? So it's really important that you start to manage your software supply chain, right? Having the software SBOM itself and being tracking the SBOM and basically in terms of the continuous monitoring of it, right? And so with all these threats that is coming out, it's very important to make sure that you have a high level, good coverage in terms across your entire applications, not only limited to kind of basically, your dependencies, your containers, but also including your source codes and basically having like secret detections, infrastructure as code, right? And of course, employing some dynamic testings, things like DAST and basically fuzzing capability, right? Especially to take care of basically your APIs, right? So once you have that good coverage, that comes into kind of basically the remediation. So as part of the remediation, to help basically developers remediate fast, GitLab has also partnered with some third-party, learning providers like Contra, Secure Flag, and Secure Code Warrior, whereby basically we can provide that security training right within the applications, right? Or what we should say on-demand remediation guidance, right, or training, right? As you get scans results, you can immediately click and get a license that is on train on that, right? So we'll now head into exercise number 5. So in this exercise itself, we're going to go through. Let's set up an on-demand scan, right? So let me just go to the project that I previously had. That's it. So besides having scans that is happening on your pipeline, whereby on commits or even on merge request itself, it actually triggers on your pipeline or different scanners, right? You could also have ad hoc scans that is happening. So you can configure that very easily by UI. So if you scroll to secure and then on-demand scans on the left side. So you can click a new scans, and with this new scans, that's where basically you can give it a name and then basically give it a profile. So let's give it a name. Right. So you can see basically the scans results. So once this by hoc scans are completed, the scans can be affiliated with certain branches that you have. And as part of basically the profile, so you can set up basically a scanner profile, right? So that could be, if you're setting up something for Dusty, so I can say my Dusty scanner. And over here, you can basically select an active mode or a passive mode, right? In terms of the scanning, certain timeouts, variables, and basically certain configurations in terms of, web crawling and basically debug logs. So I'm just going to turn those ones, right? And then you could actually, that's where basically next is that with a dynamic application security testing, you actually need a running applications, right? So it's important that basically, you need to have the URL of the deployed website, right? So you could just select and then set up basically a new website. So you kind of basically need to provide a website name, right? So let's just provide. Right, and then I can just put in like example.com, right? So and then you can have certain excluded URLs that comes inside there. You could also add in additional request headers or enable authentication if they are out there. So to give it more intense or basically deeper cross that comes with it. Right. So I'm just going to save this. So once this is done, right, so you can actually, immediately save and run the scans, right? Or you can actually enable a scan schedule to do that, right? So in a way, this will be an ad hoc scans that comes with it, right? So I'm not going to run this scan because it might take some time, right? But to just give you some idea of what happens, right? So let me just go to some previous results that I have. So you can see over here, if I go to my on-demand scans, that's where basically I have scans that was being executed, right? And you see targeted things, right? So it's targeting this particular IP, and this is basically an applications that I've set up previously, right? So it's a simple nodes application, right? So the DAS is targeting against this, right? And once this is done, so this is basically, pegged against the main branch. I specified that this was against the main branch. So if you go into basically your vulnerability, if you go into the vulnerability report itself, that's where basically you can get in terms of the Dusty results. And with the Dusty results, that's where basically you get very similar things. So you kind of basically get the different high level descriptions with medium severity level, what are the scanners that we are deploying. So with DASTs, we actually have three types of scanners itself. We kind of basically got proxy scanners, we also got browser scanners, right? And then that can actually do much more in deeper scans that comes with it, right? So with a DASTs, we basically an attack that's happening on basically a real applications, and what happens is that you will be able to get back, a request and response. So this helps you to understand in terms of, the exploitability of this particular detection, right? So this also provides in terms of evidence that comes with it, right? So that kinds of basically sums up in terms of step one. So if you want more information on basically our DAST scan, so you can actually click the link that is shown on the tutorial, right? So to head into kind of basically, as part of the approval process, you kind of basically want to understand who has approved what, etc. That's where basically you can head into the audit events. So on the audit events itself, on step 2, right? So there you'll be able to see kind of basically, all the different activities that was being handled or that was being added on the website itself. So things that is happening, things like, approval rules, how number of approval rules that comes with that, right? Having basically a site profile. So all this is being kept track, right, within the audit events, right? So you can use that as part of your tracking of the important events, right? So stepping into step 3 itself, right? So as we mentioned, so we got quite a good coverage across with all the different scanners, right? So you could also, customize the scanners. Maybe you might be, want to customize in terms of rule sets, etc. So GitLab does support that capability, right? So to do that for customizations, it's also very simple. So you can go to security configuration. Over here, that's where basically you can just click, the button and basically upload in terms of specifying in terms of the options that you want, right, to define so, right? And it details down in terms of, all the different, what you call it, all the different scanners that you have. So if you remember just now, I actually have my Dusty scanner, so I can actually manage also my different profiles that just now I also set up one, right, that comes with it. Right. So on dependency scanning, so if you remember just now, I also mentioned we have this new experimental feature that is called continuous vulnerability scans. So what happens is that once we have a trace of basically the software bill of materials that you have, the SBOM itself, we'll do a continuous monitoring when new vulnerabilities pops up on dependencies that you're using, right? You'll actually get an alert on that, right? You'll be actually be reflected on the vulnerability report as well, right? So you can actually do simple configurations that comes with it, right? So you can refer to our configuration guide in terms of how you can actually better configure those, right? So additional to that, we also have basically vulnerability management, right? So if you remember just now, I was mentioning that, once you have all the good coverage in terms of scanners that produce basically the findings itself, right? And in case that developers might not be, trained or basically they have forgotten about all this different vulnerability itself, we have integrations with third-party security training vendors, right? So right now we support 3 of them, right? Contra, Secure Courier, Secure Flag, right? So let's just enable them to see like the effect. So some of these providers, they actually provide free licenses. Yeah. So you can actually, have a trial or basically try out those, right? So I've just enabled basically this configurations. And right now, if I just click back into the vulnerability report, and we can just zoom into, for SASTI's results, and just find something that has, if you target something that's medium. So you can see how you can actually filter. So I'm just going to pick this particular vulnerability that is talking about, kind of basically SQL command, right? So over here, you got all the different descriptions of what this SQL, why this is a SQL injection, right? How to actually fix it, right? So you also have our capabilities in terms of our AI to help you to explain this particular vulnerability, right? That's in context of, your source codes itself, right? But we also have these integrations with like, the training providers, people like Contra. So you can actually click and then it will bring you to a particular e-learning, right? Or interactive learning whereby they will bring you step by step, to walk you through in terms of what is an SQL injection, how SQL injection can be exploited, right, on your applications itself, and then how to fix that, right? So we have this, and then, yeah, so you can actually take a try at that, right? So we're going to step into step 5, step 5 actually. Yeah, so there's a typo here. So this is supposed to be step 5 co-owners, right? So I think in just now in the merge request that we have provided, you can actually see you can use security policies to kind of basically get in terms of your security findings, right? That comes with it, right? And then have different approval process that comes with it, right? So what if you do not want, kind of basically people to edit the particular file, right? So that's where basically you could apply, what we call co-owners, right? To actually define explicitly that this file belongs to this particular owner, right? And then basically if somebody wants to change it, then he needs additional approval that comes with it, right? So I'm just going to go to basically the repositories that is being shown, right? My project repository, and I'm just going to go into my main branch, right? And on my main branch, I'm just going to click edit and web IDE. So this brings our IDE, and on the IDE side, that's where basically I can add in a co-owners file. So I'm just going to co-owners. So you have to name this on uppercase, and I'm just going to paste this. And I have to change this ID to basically, a handler that I have. So in this case, I'm just going to change it to, perhaps change it to Ben. Yeah. Ben's handler. Yeah. So, and I'm just going to commit this to the main branch. All right. So once I've committed this to the main branch, and if I'm to just go back to my merge request that I previously, so, and just try to do the changes, right, on a YML file. So in this case, I actually have a .GitLab CI YAML file. I'm just going to input, just an empty space. Line. Yeah. Just commit that as part of the merge request. So once I've committed that, and then if I now go back to my merge request, I'll to just so you can see over here, there's basically a different co-owners that comes with it. Right. So apparently this is being approved because I think this is opened up by Ben. Right. So it automatically approves it because Ben is the person that is authorized to basically, change this particular GitLab.yml file that was being shown here. Yeah. So if Ben was not being authorized, what happens is that another approvals will actually kick in. Right. So that's basically how, how co-owners approvals will actually kick in, right? And we also on underneath here, we actually have the documents for basic co-owners. So you can just take a look at basically the GitHub recommendations that comes with it. So that is the end of lab 5. Yeah, I'm just going to do a quick pick. Is there any questions? No questions? So I'm just going to go back to lab 6. So this is the probably last section of basically our of our lab, the final lab, is actually kind of basically to move your project into your own namespace, because this particular test group will be deleted, right? So please only make sure that you only transfer. It is optional, right, to whether you want to transfer the project, right? But if you want to transfer it, so just note that, because you might not have a GitLab Ultimate licenses, you will lose some of the capabilities when you transfer it, right? So if you are already a licensed Ultimate users, you will not be affected, right? So I will not do this transfer of projects, but just quickly walk through the tutorial that is stated over there. So you can see over here, so this will be basically the steps in terms of transferring. So everything can be kind of basically done over the web UI itself, right? So just note that, in some cases, if there are like images in the container registries, you have to clean it up, right? Before you can be transferred, the projects can be transferred, right? So if you want to do certain transformation, that can be very easily done through, the different options itself, right? Just to quickly run through, so you could actually go to the particular project under settings, right? Under general, and from general itself, if you head in downwards, that's basically the advanced. So on the advanced, that's where basically you could actually have the capability to transfer the different projects to the namespace of your preferred namespace, right? Or your personal namespace that was created, right? And you can also transfer at a group level, right? So at the group level, this will mean that basically everything that includes basically not only just the workshop project, but also the security policy project will also be transferred over to the namespace, right? So just take note that basically if you do not have ultimate license on your personal namespace, on your namespace itself, right, you will lose certain capabilities. So in terms of like securities, scanners, viewing of capability to our dashboards and for security policies. So just go back to the oops. So just to quickly sum it up, right? So during this workshop itself, we have actually explored some of the amazing capabilities that GitLab could actually bring to your organizations, helping you to shift securities and compliance left, right? Helping in short, is really helping you to deliver fast, secure, right? In terms of your development work cycle itself, right? To reduce basically, catch issues early as much as possible, right? And basically from a compliance governance perspective, that's where basically you have compliance frameworks and policies, right? To help you assist with kind of basically reportings and enforcing scans, right? Or basically blocking mergers, vulnerability going into your single point of truth, which is basically your source code repositories, right? We also saw how you can actually, review the results that comes with it, the scanning results, right? And then, the help that is offered by GitLab in terms of the remediation advice, using AI to provide more in-context remediation advice, links to basically your third-party, training vendors to provide on-demand learning, right? As required, right? And then after that, we went into supply chain and software supply chain, right? Where we kind of basically looked at our SBOM with capabilities, right? So through SBOM itself, we can actually produce, a listing of basically the different dependencies that you're using. So things are like your open source dependencies like Log4j, right, down to your container-based images that you are using, right? Additional to that, there's also providing license compliance, right? Because as mentioned earlier on, so there are some intrusive license, right, that is not allowed, that is going to impact in terms of your IPs, right? And then we also have policies that can be enforced onto this license compliance, right, to block out all this, license infringement issues that comes with it, right? And as you kind of basically head into, as part of your, not only as having scans as part of your pipeline itself, you might have on-demand scans that's happening. Sorry. So that's where basically, you can configure GitLab to have scheduled scans that's happening, separate off your pipelines and basically provide the results same in context on the same GitLab UI. So all in all, when shift left is being done well, right? So we can actually get a good night's sleep. That's the most important of everything, right? So through GitLab, security capabilities itself, we can actually help you to shift left. And if you see that we have very comprehensive coverage, from static analysis down to real-time scans down to basically dynamics scans itself, right? And all this happens within that single web applications, GitLab web portal, web UI itself, right? So developers no longer have to switch between different tools, grab another report from another tools and then try to decipher and then remediate, right? So most important of all is that, as part of the DevSecOps itself, is everybody coming as one from all the different teams, from the developer team, the security team, and the operation teams, right? And add on with basically in terms of, governance and basically controls that comes with it, right? So with this, basically, we end our workshop today. So thanks for your time today, right? So before we go, kind of basically just want to, highlight on some of the housekeeping, right? Our workshop outro, right? So as mentioned earlier on, so basically the recording and slides will be sent to you latest by next Monday, right? So if you do want it to be sent earlier, so do feel free to email us at apacfield@gitlab.com, right? And also as a reminder itself, you actually get to see a link in basically the chat to a survey, right? So please help to actually to fill that up, right? So you will stand a chance to win a North Face backpack, right? And right. So we welcome your feedback, right, to build more great app workshops with you guys, right? And if you have any questions, etc., you can actually, connect to basically one of our sales reps, right, or on our website itself, right, if you have any questions, right? So that's all. So before we close the call, probably it'd be good to check if there's any questions. So I think there's no questions, right? So yeah. So really appreciate your time today. Another friendly reminder just to note that basically your license or basically the test environments that you have is valid for 48 hours, right? So do feel free to play around with it, right? And yeah. And let us know. Yeah. So have a good day. Bye.